Hello everyone, welcome to my channel X equals to math. Today we have come with a new problem that tells you have to prove that minus pi by 2 to plus pi by 2 dx by 1 plus 10 to the power 4x equals to pi by 2. You have to prove this definite integral. Before solving this equation, here we see that the lower limit and the upper limit of the integration are basically same, but they are opposite in sign. So when you will face this type of problem, you have to check the function is whether it is even function or odd function. Let us start the solution. So let I equals to the total integral minus pi by 2 to plus pi by 2 dx upon 1 plus 10 to the power 4x, and now we'll take this function 1 upon 1 plus 10 to the power 4x as fx. So further let function of x equals to 1 plus 1 by 1 plus 10 to the power 4x. Now we will check whether this function is even function or odd function of x. So you will reflex x by minus x in the both the sides. So we further get now we get function of minus x equals to 1 by 1 plus 10 to the power 4 of minus x. Now obviously, since 4 is an even number, so the value of 10 to the power 4 of minus x should be 10 to the power 4x. So we get function of minus x equals to 1 by 1 plus 10 to the power 4x, which becomes identical with the function of x. So since here we clearly see that function of minus x is equal to the function of x, so we can definitely say that function x is an even function. So therefore function of x is an even function, and so we will use the basic property of definite integral. We know that if since the function of fx is an even function, so minus a to plus a function of x dx can be expressed as 2 into 0 to a function of fx dx. So using this formula, we will now write the expression of I equals to minus pi by 2 plus pi by 2 dx upon 1 plus 10 to the power 4 dx as 2 into 0 to pi by 2 dx by 1 plus 10 to the power 4x. After this, now we'll use the another basic formula that goes like 0 to a function of fx dx equal to 0 to a function of a minus x ds. So we get from the using this relation, we get here what we'll do that we replace x by pi by 2 minus x. So replacing x by minus pi by 2 minus x, we get I equals to 2 into 0 to pi by 2 dx by 1 plus 10 to the power 4 pi by 2 minus x. Now 10 to the power pi by 2 10 to the power 10 pi by 2x whole to the power 4 becomes cot to the power 4x. So since we know that tan of pi by 2 minus x, so we know that what we know, we since tan of pi by 2 minus x equal to cot x, so this becomes cot to the power 4x, and writing cot to the power 4x as 1 by 10 to the power 4x, and then we what get, then after solving this we get I equals to 2 into 0 to pi by 2 10 to the power 4 dx by 10 to the power 4x plus 1. So we will write this an equation 2. So what we have suggest, we have earlier we have earlier taken I equal to this one as 1 and this equation as 1, and now we take this equation, and now we take this equation as 2. So adding 2 and 1 we get I plus I equal to 2 into 0 to pi by 2 tan 4x dx by tan 4x plus 1 plus 2 into 0 to pi by 2 dx by 1 plus tan 4x. I plus I makes 2i, and taking, and here we get, see that the two LCM are same, since denominator are the same, denominator of the two integrands are same, so we can easily add them, and after adding we see that the numerator and the denominator, they become both equal, so we can easily cut them out, they cancel each other, leaving only dx. So finally we get y equal to 2 into 0 to pi by 2 dx, and the integration of dx, you already know that is very simple. The integration of dx equal to x, and putting the upper limit pi by 2 and the lower limit 0, we finally get I equals to pi by 2. In the starting of the problem, we have set let I equals to minus pi by 2 to plus pi by 2 dx by 1 plus tan 4x. So finally we get the answer, that is minus pi by 2 to plus pi by 2 dx by 1 plus tan 4x dx equal to pi by 2, proved. This is the problem that ends the problem. And if you like the solution, please comment, and do not forget to subscribe the channel. And now, before signing off, we want to share a thought from a legendary person, Nelson Mandela. Always keep that man in your life, that the greatest glory of in living lies not in never falling, but in rising every time we fall. Thank you.